Alright, here's an example for finding the domain of a composite of two functions. So we're given two functions. We're given f of x is defined to be equal to 2x minus 5, and g of x is defined to be equal to the square root of x plus 7. And we're asked to find the domain of a composite of the two, G composite F. And our solution, the first step we'll do is, for finding the domain of a composite, is find the formula for the composite. Okay, so we have G composite F of x. Well, by definition, that's equal to G of F of x. So the next line, you just replace the F of x with what it's defined to be equal to on the top. We're given that it's 2x minus 5. And finally, we evaluate the g function for the value 2x minus 5. Well, the g function at the top told us whatever you feed into g, you add 7 to it, and then you take the square root. So we're going to take what we fed into the g function was 2x minus 5. Okay, that's what we fed into it. We're going to add 7 and then take the entire square root. So that means when we simplify, that G composite F of x formula is the square root of, well, we got the 2x, and then the negative 5 plus 7 is positive 2. Step 2. Step 2 is find the domain of the formula for the composite. Okay, well, the composite formula is the square root of 2x plus 2. And the only restriction we have on x is we are not allowed to have x values that makes the radicand negative. In other words, the trash under the radical sign has to always be greater than or equal to 0. So we set the radicand 2x plus 2 greater than or equal to 0. That's what we have to have, because if we're less than 0, it would be negative, and we can't take the square root of a negative number. Now we subtract 2 from both sides. We get 2x is greater than or equal to negative 2, and then we divide both sides by positive 2. We get x is greater than or equal to negative 1. And that gives us the following domain of the formula: everything from negative 1, including negative 1, to positive infinity. So that's the interval notation for the domain of the formula. Let's go to step 3. Here we have to find the domain of the inner function. The inner function in the composite. Well, we composed G compose F is what they want us to find. G compose F. So I would say that in the composition G compose F, F is our inner function. Thus, the domain of F is the domain of, let's see, what is F? Of 2x minus 5. Okay, which is equal to all real numbers. There's no restriction on what x can be when you're looking at 2x minus 5. I mean, we don't have a fraction to worry about, we don't have a radical, so it's just all real numbers. And in interval notation, it's open interval from negative infinity to positive infinity. Okay, Now step 4, I need to find the domain of the two put together. In other words, I'm finding the domain of the intersection of these two, step 2 and step 3. So to do that, I'm going to stack number lines. Find domain of let's see, the formula intersected with the domain of the inner function. So first we'll have the domain of the formula, which we got in step 2. Here's a number line. And you can see back in step 2, that was everything from -1 to infinity. And it included -1, so we get a boxy bracket, and we shade everything out to infinity. And then we have the domain of the inner function, which is what we found when we did step 3. So we're stacking number lines. Put the -1 right there. The domain of the inner function from step 3 was all real numbers, so we shade the entire number line. And finally, the intersection of the two, put a number line right below, put the number -1. Now, we're only shading regions that are x values that are shaded in both of the sets above, because intersection, like the intersection of Hollywood and Vine, it includes only real estate that belongs simultaneously to both Hollywood and Vine. So you see, from values of x that are less than -1, we do not include those in the first set. They're not shaded. They're only shaded in the second set, and that is not enough to put it into the intersection. But for values greater than -1, we do have shading. We are including those x values in both sets. And for -1 precisely, it is included in the first set with the boxy bracket, and -1 is included in the second set because it's shaded right through it. So yes, it will be included in the intersection. That's why we get a boxy bracket. Now that is our solution. Thus, the domain of G composite F, we went through all the steps, is equal to, now let's write this in interval notation. The smallest value shaded is -1, and the largest value is infinity. We include -1 with a boxy bracket. We do not include infinity, and that is our final answer. Those are the x values in the domain of G composite F.